Hi Expo Algebra, this is Mr. Monahan. This video is for the 8B practice test. Feel free to fast forward or rewind, whatever you need. Your Chapter 8B test is coming up really soon, and this is what it looks like. The first thing I would say about this test is all the directions are the same. It's factor each expression completely. So you're going to do as much as you possibly can to all of these problems. So how much can you possibly factor these? The first three right here, 1, 2, 3, these are all GCF only. Okay, what that means is after I do the GCF, there's nothing else that I can do. So for number 1, the first thing we might look at is it a difference of squares? And it's not. 4 is a perfect square, but x and 12 are not. So all we can do is take out a GCF of 4. So our GCF is 4. That means that goes first in my answer. And then we divide both of these by 4. When we do that, these 4's will cancel. I'm left with just an x, and negative 12 divided by 4 is negative 3. Okay, this one is actually something we learned in Chapter 8a, looking at just do the GCF and then move on. The second one, 10x plus 15, has a GCF of 5. You can divide both of those by 5. So 5 is the first part of my answer, and then I can divide both of these by 5. 10x divided by 5 is 2x. I see a plus sign. 15 divided by 5 is positive 3. So that would be it for number 2. The third one might have been the most confusing of them, the GCF of that one. Okay, we can take a 3 out of all of those, but also an x. So when we do that, it looks like it's something that we might be able to factor when we're done. Don't forget the 3x out front for part of your answer. Okay, it looks like we might get something that's able to be factored, but it actually doesn't work out. So these 3's will cancel. We're taking an x away from each of these, so the first term will be down to x squared plus 6 divided by 3 is 2. We're taking an x away, so there's only one left, plus 15 divided by 3 is 5. Okay, and then the x's here will cancel. So you could look, now we have a trinomial in here that looks like maybe it could be factored. But if you look at this, it would have to be a plus-plus problem. And there's only one way to multiply to 5. It's 5 times 1. But 5 plus 1 does not give us the 2 that we need in the middle. So this is actually just not factorable on the inside. So all we can do is the GCF. So it's GCF only, number 1 through 3. Okay, so that's actually technically review from Chapter 8a. So now we would move on to the new type of factoring, what we know how to do now. So number 4, let's move on to that. The first thing you want to look at when you're factoring is what the sign should be. So for this one, we're going to want, if everything is positive in the original problem, we're going to want to use plus and plus. So we're going to use plus and plus. If there's only an x squared out front, we know that we break that into x times x. And then this is that first version of factoring before there's a number in front of the x squared. What we want to look at is what are the factors of 60 that multiply to 17, that multiply to 60 but add to 17. So we have 1 times 60, we have 2 times 30, we could do 4 times 15, we can do 6 times 10, and then we can do the one that we're missing, the one that we need, 5 times 12. Okay, so those are going to be the ways that we can add, or multiply to 60. We want the ones that will add to 17, and that's going to be our 5 times 12. So we need the 5 and the 12, because 5 times 12 is 60, but 5 plus 12 is 17. And you could have the 5 and the 12 in there backwards. Okay, next one, when only the middle term is negative. Okay, when only the middle term is negative, okay, then we look at this as being a minus-minus problem. Okay, we still have x times x as our only choice right there. Okay, but 24 We can do 1 times 24, we can do 2 times 12, we can do 3 times 8, or we can do 4 times 6. Okay, what we want to look for is the one that makes 11 when we add them together, and that's going to be 3 times 8. So it's just, for this type of problem, it's going to be negative 3 times negative 8. It doesn't matter where the 3 goes and where the 8 goes for a problem like this. Okay, negative 3 times negative 8 is positive 24. And then negative 3 plus negative 8 is negative 11. Okay, number 6. Okay, it doesn't matter what's happening in the middle. If the last term is negative, we use 1 plus sign and 1 minus sign. Automatic. Okay, we know we can put our x and our x in those spots there. Okay, now it's like a subtraction problem instead of an addition problem. So we want to add to negative 1 in the middle, or positive 1 in the middle. So what we do now, the way that it's different, is we look at which factors of 20 are 1 apart. 4 times 5 is 20, but I can do 5 and negative 4 to get positive 1. So if I want to try to do that, okay, we have our 5 we want to put by the plus sign, our 4 by the minus sign. If the middle term is positive, we want our bigger number by the plus. What that does for us is these two make 5x. These two make negative 4x. When you add those together, that gives you positive 1x, which is exactly what we wanted in the middle. Okay, let's move on to number 7. Number 7, x squared plus 11x plus 28. So this is going to be back to a plus plus problem. We look at 28. We look at that last term. And we look for which ones add to 11. Okay, it doesn't matter which one is the 7 and which one is the 4. But we're looking for the two numbers, my apologies, the two numbers that multiply to 28 and add to 11. Number 8 is a negative final term. So I know right away that I need 1 plus sign and 1 minus sign. It doesn't matter what order those are in. But I know that that's what I need right away. X squared is still just x times x, so there's not much going on for that piece until the next row down. And then we're looking for the factors of 6 that are 5 apart. So this one can be potentially tricky because you might look at 2 and 3 as, hey, those add to 5. But you got to remember one of these have got to be negative. So we want to look for the ones that are 5 apart. So if we do 1 times negative 6, that gives us negative 6. But then also, negative 6 plus 1 is negative 5. Remember, these two make positive 1x. These two make negative 6x's. And that gives us our negative 5x in the middle. Okay. Whatever you put first has to multiply to the first terms. Whatever you put in the last spots have to multiply to the last number. And then the O and the I from FOIL need to add to the middle. All right, number 9, only the 13 is negative, so that brings us back to the minus type of answer. Only x's in the first spots, okay, and then we can look at 40, and we can look for what makes 13, and that's going to be 5 times 8. So 5 and 8 in either order. Okay, negative 5 times negative 8 is positive 40, and negative 5 plus negative 8 is negative 13. Okay, moving on, now we're into the ones that will have a little bit of a different approach. So with the numbers out front. So as soon as there's a number out front, like this 5x squared, the first thing I would check is there a GCF? Could we make these numbers smaller by dividing? Okay, this time we can't. So what happens now, what happens differently, okay, we still know that it's a plus and a plus. That hasn't changed. Okay, but what we have to worry about now is how can I make the first term? Okay, so now for the first term, it's not just x and x, it's 5x and 1x. And it doesn't matter which order I put those in at this point. Okay, then we have 6, so we can do 1 times 6 or 2 times 3 for that. Okay. And what we want to try to do is still add to this 17, but whatever goes in this spot right here gets multiplied by 5. Okay? So we need to do 5 times something in that list of factors of 6. So I want to try to get as close as I can to 17 without going over. 5 times 3 is something that would be smart to try right away. If I put a 3 in this spot, I need a 2 in this spot because I need to be able to multiply to 6 still at that point. And just let me give myself some more space. But the reason that this works, okay, we always check it with foiling. Every problem on this test, you can make sure that you're right by just foiling it out. Okay, these two give us positive 2x. These two give us positive 15x. And that gives us that positive 17 in the middle. So what makes these ones a little bit trickier is they're just a little harder to get the number in the middle to work out the right way. So number 11, same thing I would say. Can we look and see if we can get a GCF to come out? But 2 and 11 and 5 don't have any common factors. So I see that negative 11, that's the only negative in my answer. So I'm going to use minus, and I'm going to use minus. Okay? There's only one way to get to 5. There's 1 times 5. There's only one way to get to 2. That's 1 times 2. So I'm going to make one of these first spots 2x, and one of these first spots 1x. Okay, I'm just going to put those down. Since it's a minus problem, I can't really put those in the wrong spot. Now, I want to try to make 11. So again, whatever I put here gets multiplied by this 2. So I want to try to do 2 times 5 this time. So I'm going to try to put a 5 here. That gets me to 10. Then what's left here is 1 times 1. And that actually gives me a total of 11. So these two multiply to negative 1x. And these two multiply to negative 10x. And if you add those together, you get negative 11x. That's our answer for number 11. Okay, number 12, again, you have a number in front, but first thing I would say is, can you take a GCF out? This one has a GCF. Okay, you could take 5 out of all 3 of those numbers. So the first thing I'm going to do is put a 5 down, and then I'm going to divide everything by 5. So this is kind of what I would look for work on a problem like number 12. So these 5s will cancel. That's just x squared now. Plus 30 divided by 5 is 6x. Plus 40 divided by 5 is 8. Okay, now, kind of like number 3 above, we're left with what looks like number 3 above. But this time, I can multiply two things that multiply to 8, but they also add to 6. So that'll be 4 times 2. So I see plus signs everywhere, so I'm going to do plus and plus. I've gotten rid of, there's no number in front of this x squared now, so I'm just down to x times x. And then it doesn't matter where the 2 goes versus the 4 for this problem. So if there's numbers out front, you still always want to check for, is there a GCF? All right, let's move on to number 13. Okay, so I have that same one in there again on accident, no problem. We're done with those. All right, number 13. This is called a difference of squares. Okay, so number 13 is called a difference of squares. And it's a pattern that you need to know. And actually, that's number 14 and number 13. So what happens with difference of squares is you get some a squared minus b squared, both of your terms. It's only a binomial, and both of them end up being perfect squares, and it always factors into this pattern. Okay, it's a plus-minus problem, and all we need to do is find the square root of each term. So you're looking for, how can I split x squared into 2 of the same thing? That's x times x this time. I can split 49 into 2 of the same thing, 7 times 7. So what happens with this, as long as this is a minus sign in between, and this time it is, it factors the same way. X's are my first spots. I need 1 plus, I need 1 minus, and 7 are my last spots. The reason that works is if you FOIL that out, you'll see a 7x and a negative 7x, and those are going to cancel each other out. 14, okay, can I break 9x squared into 2 of the same thing? Well, 9 is just 3 times 3, and x squared I can write as x times x. So I can write this as 3x times 3x. 16 is a perfect square. I can write it as 4 times 4. So the answer, 3x plus a 4 and 3x minus a 4. They're exactly the same sets of parentheses. You just have one of them positive and one of them negative. All right, and 15, let's try before factoring this, let's try taking out a GCF. Okay, anytime you see an exponent bigger than 2, I would check to see if we can do that. So it looks like I can take a 2 out of all 3 of those numbers, okay, and I can take an x out of all 3 of those terms. So I'm going to divide everything by 2x, and that's going to be my first step. Okay, after that, we'll see if we can factor what's left. So here we would have 2x squared, positive 1x, and negative 15. And this is something that we'll be able to factor, so I'm going to set up our next step. Okay, the 15 at the end is negative, so I need 1 plus and 1 minus. Okay, I need to have, for 2x squared, I need to use 1 times 2. I'm going to put a 1x in one spot and a 2x in another. Okay, and then 15 has a couple of factors. The one I'm going to focus on is 3 times 5. Because if I'm able to do 2 times 3, that's 6. And then I would be left with 1 and 5, which makes 5. 6 and 5 are going to be 1 apart, and that's what I want. Okay, so I want to be able to get 2 times 3 and 1 times 5. The reason that works, that gives me 6 x's. This gives me negative 5 x's, and that's my positive 1x. GCF first. If you can. You always want to use the GCF if it's there, if it's possible. All right, and then all that's left are some word problems. However, the word problems are just the same as the non-word problems. All we need to do is factor. So number 16, a cereal box in the shape of a rectangular prism. That just means a 3D box. It's just a box. Has a volume of 12x to the third minus 22x squared minus 20x. It says, what are the 3 possible linear expressions for the dimensions of the box? And then it says, hint, the dimensions of the box are the factors. So what we're really looking for on a problem like this is just the length, the width, and the height. So if we have a box, okay, it's going to look something like this. Okay, what we're really looking for is the length, the width, and the height. Okay, that's how you get volume. All that we need to do is take what they gave us. The volume is this. Oops, that's a 3, my fault. 12x to the 3 minus 22x squared minus 20x. Okay, all we need to do is factor that. So the word problems, you're still just going to factor the same way you've been doing everything else. The first step of that is going to be to take a GCF out. So can we take a GCF out of 12, 22, and 20? They're all even, so I'm going to try dividing them all by 2. Then they all have an x in it. So my GCF is going to be 2x, and then I'm going to have a factoring step after that. So I need to divide everything by 2x first. Okay, that gives me 6x squared out front, negative 11x in the middle, negative 10 for the last piece. Then I need to factor that. So I'm going to end up with 3 answers, where this is kind of my length, this is kind of my width, this is kind of my height. Okay, so that's what we're looking for. We're just factoring it. So for 6x squared, we could do 1 times 6, and we could do 2 times 3. For 10, we could do 1 times 10, and we could do 2 times 5. And then 2 times 5 is going to be a good place to look for that answer. So first, it's going to be plus and minus, because we do have a negative 10 in that last spot. Okay, and then what we want to do is add up to that negative 11. So in that case, what we can do is try to look for a way to get close to 11. And I see that we have a 3 times a 5. That could give me 15. So what I'm going to do is I'm going to try to set that up to be a negative 15. Okay, 3x in the first spot, 5 in the last spot. If I use a 3x, that means I have to use 2x here because I still need to make 6x squared. And if I put a negative 5 here, I need a positive 2 in that spot. What that does for me is that gives me positive 4x's and negative 15x's. 4 minus 15 gives me that total of negative 11 in the middle. Okay. So even though it looked like it should be a tougher problem, it's really the same directions. Can you just factor that? Okay, and then the last one on the practice test, which might be the last one on the real test, It says the area of a rectangular serving tray is 5x squared plus 7x minus 6. They're telling you the width of the tray is x plus 2. They're asking you what the other dimension is. So this actually should be a little easier than factoring because they gave us half of the answer. If this is x right here, whatever I put in this spot has to multiply to 5x squared. So this is like a 1x. I need to multiply. I need a 5x right there. 5x times 1x has to make 5x squared. Okay, so that's what has to happen with those. Then I know I need to make a negative 6. I have a positive number here, so I need a negative number there. Okay, so in that situation, I need to do 2 times negative 3 because these two need to multiply to negative 6. And that's my answer. I'm not even really concerned with adding to 7 in the middle. I know that it will because otherwise the problem is just bad. But number 17, they give you half the answer. You just have to make the front terms work out and the last terms work out, and then you're good. All right, that's everything you need to know for Chapter 8B test. Make sure that this makes sense. Ask your teachers for help, and good luck on that test upcoming.